Good morning everyone. Today we will be discussing the tutorial and the demonstration of differential scanning calorimetry, that is DSC. Calorimetry is the study of heat transfer during physical and chemical process, and the device for measuring this heat transfer is called calorimeter. Differential scanning calorimetry or DSC is a category of thermal analysis of a sample which is basically used to measure the temperature induced changes and explains the physical and chemical properties of any sample. DSC measures the difference in the amount of heat that is required to increase the temperature of a sample and the reference as a function of time. Here both the sample and reference are kept at the same temperature. There is one condition that is followed is that the reference sample should have a well-defined heat capacity throughout the range of temperature where scanning is taking place. Differential scanning calorimetry depicts the graph in the form of endothermic and exothermic transition. To maintain the sample and reference at equal temperature during the physical transformations of the sample, either more or less amount of heat is required. This heat required depends on the nature of the transformation, whether it is exothermic process or endothermic process. By calculating the heat flow differences between the reference and the sample, DSC technique can determine the amount of heat released or absorbed during a transition process. This is the basic diagram of DSC. This is how a simple DSC looks like. It has a heat driver, thermocouple, heat resistor, amplifiers. These thermocouples are the detectors in DSC. DSC consists of a measuring cell which contains a furnace and an integrated sensor that has designated slot for sample and the reference. The sensor part of the cell is connected to the thermocouple. Now these thermocouples have a role of recording the temperature as well as the temperature difference, which is basically required to calculate the heat flux. These are the basic parts of our DSC. First there is detector. Thermocouple is the detector here. It is used to measure the temperature change while the sample is heated under controlled environment. For the case of low temperature, copper constant thermocouple is used, and if the experiment requires high temperature container, for high temperature, platinum or ceramic sample container is used, and if the temperature is low, then aluminium sample containers can be used. Reference material can be calcined alumina or carborundum. Temperature controller is used to maintain the temperature of the reference and the sample at the desired value. Then there is furnace. Uh, one block of furnace is required in case of heat compensated DSC, and two block of furnace is required in the case of power compensated DSC. These two are the two types of DSCs. There are basically two types of DSC. First is heat compensated DSC, and another is power compensated DSC. In heat compensated DSCs, sample and a reference crucible are placed on a sample holder integrated with a temperature sensor. This is very compact and lightweight system having low heat capacitance. However, in the power compensated DSC, both the crucibles are placed in thermally insulated furnace and not simply next to each other. This is the basic diagram that we acquire after performing the DSC. DSC consists of a measuring cell which contains a furnace and an integrated sensor. This graph includes both the heating and cooling profile of the sample as per the sample requirement. As for different convention, exothermic reaction in a sample depicts the positive and negative peak. DSC is widely used to get information about melting point of the sample, crystallization temperature, heat of crystallization, and the heat of melting and glass transition temperature. These are two DSC profiles. One is for lauric acid and one is for myristic alcohol. As you can see, there is one endothermic peak in the case of lauric acid, and there is one exothermic peak. The onset melting and freezing points are 42.5 degrees Celsius and 40.1 degrees Celsius. In myristic alcohol, there is one endothermic peak and there are two exothermic peaks. The onset melting and freezing points are 38.25 degrees Celsius and 35.84 degrees Celsius respectively. There are few factors that affect this DSC curve. First are instrumental factors. These may include heating furnace heating rate, furnace atmosphere, recording speed, geometry of sample holders, location of sensors, sensitivity of the recording system, and material of the sample container. The other is sample characteristics. Parameters including weight of the sample, particle size, solubility and evolved gases in the sample, heat of reaction and thermal conductivity. There are many applications of DSC. It can be used for studying heat of melting, crystallization, percentage of crystallinity, heat capacities, thermal stabilities, purities, oxidative stabilities, etc. This is the instrument that we'll be using today for performing the experiment. This is DSC 200 F3 Maya differential scanning calorimetry from Nest Premier Technologies. The temperature range for this instrument extends from minus 60 degrees Celsius to 600 degrees Celsius. The main features are newly developed monolithic DSC sensor and new silver furnace with long life heating element. The heat flux sensor combines high stability, improved resolution, and fast response time. Thank you.